updates?
I do.
All right, let's hear them.
All right. So I got a couple of interesting results. The first one says that only validators can slash, and the slashed bond is distributed equally among all remaining validators. And so I would like to spend some time to explain this. So on the first claim, anyone should be able to slash a validator provided that they pay the transaction fee. And this could be specially increased for slashing to get the slashing transaction included. However, in practice, the validators will probably just replace that transaction with their own slashing transaction. And so de facto, only validators can slash other validators. Does that line of logic make sense?
I get it.
All right. So
It's slashing takes you to 0, right?
yes, that is another assumption. That is true.
Right. If slashing didn't take you to 0, then a validator could just jump on the bandwagon.
Yes, that's true. And they would take some of the profits themselves. Except, so actually, so now that relates to the second point, so assume instead that we implemented a policy saying that the first validator to create a block that includes a slashing transaction receives all the rewards. And so that's a pretty natural first assumption, I would say. And so since creating blocks in proof of stake is almost free, the dominant strategy for other validators who receive that initial block claiming the slash is to ignore it and then instead create a new block claiming that it was the first one to discover the invalid block. Since all the validators will do this, the validators who are connected well and have the most stake will win the slash bond most of the time, like regardless of whether it was really the first one to discover the invalid block. So instead, if we assume that all the slash bonds are distributed equally among the remaining validators as a policy, then the dominant strategy for validators is to pause slightly longer after discovering that invalid block, and then let the leeches, which I define as those who don't validate, to effectively build more blocks on top of the invalid block. And then both the original validator and the leeches get slashed by the remaining validators for more shared profit. And so this strategy works because the leeches, all other things kept equal, build on blocks faster than as they don't have to validate, right? So they can build on blocks faster. And so their default behavior backfires on them when invalid blocks are circulating in the network. And so, yeah, does that make sense?
Yeah, it does. I think you're making a strong rational actor assumption, right? You're assuming that everyone is rationally motivated to increase their profit.
Yes.
Okay.
Right. Mm-hmm. Is that not, I guess, like a reasonable one, if that makes sense?
I mean, it is. It's. I mean, it's a fairly standard assumption. However, we know that there are non-rational actors who just grief, or just they do things to either hurt the network or right. There are trolls. There are other kinds of actors that are not following rational tactics.
I see. Yeah, I guess. Yeah, I'll redo some thinking and report back. But my first reaction to that is that, like, it doesn't matter, even if we go back to that policy saying that the first validator to create the block that includes the slashing transaction receives all the rewards. Like, you would still get the same amount of troll behavior, and they would be. But yeah, I'll sort of think through that and report back.
No, but I mean, I think your results stand, right? As long as you just call out the assumption of rational actors, because I think that's just all through Casper's that actors are more or less trying to maximize their profit.
Yep.
Yeah.
Okay, that's the first thing. The other thing is that, so since I guess we can be a bit more chain specific, I finished implementing the specifically the neglected equivocations detection. And so I think so the important thing is that we're sort of separating the idea behind invalid blocks and equivocations. And so just to be clear, building on top of a block that hasn't slashed an equivocation is an invalid block. And however, but if you build a block that is on a block that is aware of an equivocation, then you have neglected to equivocate, which is also which is creating an invalid block. But there's a bit of a difference there, because when you build off of an invalid block, you can already identify it because you don't ever add it to your block DAG, versus when you are neglecting an equivocation, you see the equivocations, and you still have to add the equivocations to your block DAG. And so the algorithm came out to be, I guess, a bit more simple than once you sort of do that split, came out to be a lot more simple than I was sort of mentioning last week. And so I guess that's good news. I can run through it. I don't know if we want to get into implementation details, but that's one thing. And I've also started to get together a slashing API. Let me just and so let me actually screen share this. So sorry, I'm finding my Zoom window. All right. All right. Can everyone see that?
Yes.
Cool. So this is the slashing API. And so the idea is that each of these bullet points right here is going to become one API endpoint in the proof of stake contract. And so this contract is going to be in Rolang.
Mm-hmm.
And then if the same block can be slashed for multiple reasons, then you start from the top and then you go down.
Mm-hmm.
So I'm just going to gloss it quickly over, but we want to start with any invalid blocks that are missing any fields, because then we can't check for the other ones. However, we got to be careful here, because we don't want to be able to just take any, like, we don't want to take any message that has been signed by a sender and then repurpose it as a block, if that makes sense. Right?
Yeah.
Do you see that attack vector? If that makes, so we actually might want to have more minimum fields before we say that we're going to slash a block, and we should, in a sense, notify validators that you don't sign arbitrary things with your key, because people could repurpose that signature as a block signature and you will get slashed for it. So that's the big warning one. But the other ones are pretty straightforward. If your block does not lead back into the block DAG, you have to show that justification chain. So you'll end up showing x+1 blocks to the Casper or the proof of stake contract. For blocks that don't hash, so there are many hashes inside a block. This includes the main block hash, the parent hash, the post state hash, the new code hash, and the transaction receipts log hash. If if any of those don't follow from their constituents, then you show that. So there's only one block involved there. And for blocks with an invalid block number, which basically means that the parent block is not one less than the current block, then you slash that. So you show the parent and the block. And a similar thing for the sequence number, except you show the creator justification block, which is essentially like the parent in terms of the justification chain. For blocks that are missing justification pointers, you show that block. For blocks that don't match the derived parent, so essentially when you run Ghost yourself, if it doesn't match what the parent is, then you show the justifications and the parent, and then you slash that block. For any invalid transactions, essentially this is where like the bad reductions come into play. And the other careful thing is we need to include slashing transactions that are valid from the Erlang interpreter's standpoint, but are not valid from the Casper standpoint. And what I mean by that is, if someone says that there was a block with an invalid block number, for example, and they submit 2 blocks and they're actually valid, then there probably isn't going to be an invalid reduction here, but there's going to be the fact that they falsely tried to slash someone else will be and something that needs to get slashed in return. And so that's what's covered by this parentheses. And for blocks that contain justifications that lead to invalid blocks but don't slash their creator. And then blocks that contain, so this is sort of the what I was earlier saying about with the algorithm that ended up being more simple, is to detect this thing. And so yeah, and then finally for equivocations themselves, you show the base block and then any 2 child equivocating blocks, I call them, that have sequence numbers that follow. And so this is I guess I would say work in progress, but probably getting there, slashing API.
No, this is great. No, I really appreciate that. I was lost in thought about slashing wars.
Yeah. So I guess this I guess protocol tries to maximally slash. I don't know if that's the right terminology, but like it tries to slash if it can.
Yeah,
and
that's right.
and I think in a sense it's important to do so, because if you don't slash when you can, then you get this situation where you incentivize your validators to be a bit lazy.
Yes, yeah. The lazy validator thing is really bad. Yeah. No, I think this is right. I mean, I'm just part of my deliberations. I was reviewing Arrow's results and the whole tit for tat stuff, and how I was just trying to think this through from the game theoretic perspective. That's why I was a little bit quiet. But yeah, I mean, I think this looks like a really, really good formulation, to at least to begin with.
Yeah, I guess we can build more from here. I know about, was it Arrow's impossibility results in game theory?
Yeah, that's
Yeah,
right.
those are cool. Yeah,
Yeah,
I haven't walked through the proofs yet, but
yeah,
I'll
understood.
I'll, I'll take a look. Yeah.
Yeah, yeah. I was just really thinking about it through from the point of view of so I guess aggressive or eager slashing versus cooperative slashing, and um, but I think this is probably the right beginning. This is the right foundation. So yeah, cool. Any other updates?
Nope.
Kent, I wouldn't mind if we went a little bit more in depth on the work that you have been doing around your
The neglected equivocation stuff.
yeah.
Yeah. Okay. Cool. Yeah. It's pretty implementation heavy, but I guess it is Casper. So
Yeah, that's right.
yeah. So first of all, do we both agree that every equivocation has one base equivocation block and multiple children equivocation blocks, where the children equivocation blocks have a sequence number that is one greater than the base equivocation block? Is that okay?
Yeah, that makes sense to me.
Cool. So, and Mike, I think, yeah, we went over that, right? Okay. So to detect neglective equivocations, we keep a set of equivocation records. So I'm just going to read off what I actually posted this on the Casper CBC chat, but stop me if anything sort of doesn't make sense. So we have a set of equivocation records, and an equivocation record is a tuple containing the equivocator's ID, the sequence number of the base block, and a set of block hashes of blocks that point to enough evidence to slash an equivocation corresponding to that equivocation record. And so one thing I want to emphasize here is that we have these equivocation records, and one validator could have multiple entries in this equivocation record. And this is because they could equivocate once, and then on either fork, they could equivocate again. And so earlier, I was under this assumption that, well, all you have to do is look at the most historic equivocation, and you can ignore the rest. But then I realized, wait a minute, that doesn't work, because some validators could look at the more recent equivocations, and if they don't slash when they see those, then you have to slash them in return. And so we actually have to keep track of all of them. And so in any case, in each time we discover an equivocation, we add a new equivocation record entry to that set using the appropriate validator ID and base equivocation block sequence number. And each time we add a new block to our view, we loop through our current equivocation record. So usually our equivocation records will be, and hopefully actually in some sense, they will always be empty. And so when I say we loop through our equivocation records, basically it means we do no work. But in the unfortunate case that someone's being an equivocator, then we have to look through our equivocation records and see if the block we want to add has enough information to detect the equivocation corresponding to the equivocation record. And so one important thing is that we're always adding the dependency of blocks to our block DAG before we add the block that we needed the dependencies for. And so this means that whenever we include a block that is neglecting an equivocation, we have always added the equivocation itself into the block DAG. And so anyways, so there are three cases that can happen when we check to see whether there's enough information to detect the equivocation corresponding to that equivocation record. And that is A, that the block has enough information and the block contains the equivocator in its justification. And in that case, we have to slash that block. And case B is where the block has enough information, and when I say enough information, I mean enough information to detect the equivocation corresponding to that equivocation record. And if it has enough information and that block properly has rotated out the equivocator from its justification, then we update the equivocation record so that the set contains this block. And we don't slash that creator because they have properly said that they saw the equivocation. And the case C is that the block doesn't have enough information. And so in that case, we do nothing. And so is that clear so far?
So actually, the case one where they should have seen the equivocation and didn't slash it.
Mm-hmm.
You're detecting that based on.
So I haven't gone into why the block has enough information. I'm just saying that there is an algorithm that magically detects.
Yeah. No, that's fine.
Okay.
I mean, more you're detecting whether or not they were rotated out based on their existence or non-existence in the latest messages.
Yes. And so, okay.
And I'm not sure if that's totally right.
Well,
we haven't really done much work yet on what happens when a rotation actually occurs, right? We know that the weight goes to 0, but in terms of the other details of like data structures that we have, I don't know. Maybe you've thought this through already. But
yeah. So the assumption that I've skipped over is that we need to check that the justifications match the bonds, right? So what I'm actually saying is that first of all, does the justification set correspond to, the justification map, I guess that's what we're using, correspond to our bonds map? And when it does the mapping, it drops anything with a weight of 0, or it it automatically doesn't include anything that isn't in the bonds map. And then the further assumption is that that bonds map that we're keeping is based on the proof of stake Casper contract that's written in Rolang. So we're extracting out that bonds information from there. And so you first have to check for those, and that's sort of why the slashing API is ordered in the way it is, because it checks those first, and then it checks for this case.
Okay, so the idea is that there's sort of an additional validity condition on blocks, which is that you have exactly one entry in your justification per bonded validator.
Yep.
And no more.
Exactly.
Yeah, okay. So when we're checking, does this block need to be slashed or not, checking the justifications is enough, because earlier upstream we would have verified that the justification matched the bonds.
Exactly.
Okay, cool.
All right. So now I'm going to go into that magical algorithm that detects whether a block has enough information to detect the equivocation corresponding to the equivocation record. And so what we do is we take the block and we loop through the justifications, and we accumulate a set of children equivocation blocks that are reachable from that block's justification. So if you just imagine that diagram that we usually draw, essentially we go from the justification and we follow dotted lines down until we reach a child equivocation block from the equivocator. And then so we do this for every block justification. And if at any point the set of children equivocation blocks that we've been keeping track of becomes larger than 1 in size, so basically if it becomes 2, then we immediately ascertain that the block has enough information to detect the equivocation corresponding to the equivocation record. And similarly, if when we're looping through the block's justifications, if we come across a justification block that is in the set of block hashes that I mentioned earlier, then we immediately ascertain that the block has enough information to detect the equivocation. And this is because, so like that part is essentially because that set of block hashes is the set, or it corresponds to the set of blocks that have seen and said that, oh, we have detected that equivocation. So if we're building on top of it, it obviously means that you had to have also seen the equivocation through that single justification block. And okay, also, the reason you need that is because if we only looped through the justifications and then accumulated what we could see from the set of children equivocation blocks that got accumulated, we wouldn't cover the cases where one justification block could lead to both sides being discovered, both sides of the equivocation, because you only have one latest message per validator. And so essentially this set of block hashes part, it makes up for the fact that we're not doing anything funny with using sets for the latest messages maps or map. Yeah. Was that clear?
Yeah, I mean, I think that's that's a pretty detailed description. I mean, it looks good to me.
Yeah,
Cool.
sorry, my network connection dropped out partway through that second half of the explanation, but I did read the PR, so I saw the code. But I am glad that we still talked about it, because I had missed that line where you were using the latest messages to capture bonds.
That part, yeah.
Which is yet to be implemented, so yeah.
That is true, yeah.
Cool. Any other updates so far?
If we want to go into a bit of the sharding stuff, we can. But I don't know, Greg, do you have any updates first?
Yeah, I've just been thinking a little bit more about validator rewards and thinking about ways we can characterize useful work. And one of the insights, and I don't know if it yields anything, but one of the insights with respect to useful work is that you can look at these chains of comm events, right? So if you just think about it like in terms of comm events that are related to money being distributed or currency being distributed, then if the work is useful, then what will happen is, so like the household buys the milk, the milk provider pays the farmer pays the feed producer, and so on, right? So you get these chains, and if the money is flowing, if it's a real transaction, you'll see these sort of natural flows. And if it's a not useful, then you won't see them, or there'll be like tight loops or silly things like that. And this is related to other applications that I've been contemplating for a while that have to do with analytics applications where you do follow the flow of stuff around the network, so you can see market trends and things like that. So right now I'm just in the midst of seeing how badly you can game you can game a system like that. But it seems like for good for useful work, it has to cross some threshold with respect to how far the flow propagates. But I haven't found a way that I can't game yet. But this is the idea. Is I want to be able to give some kind of objective measure of whether or not the transactions are have some utility with respect to some broad clientele. And if they don't, then they're likely to be busy work generated by the validators in order to collect rewards.
I think it's hard to measure something like that because the blockchain isn't entirely a closed system, right? Like if I have some piece of information, say I want to do a proof of existence, and so I hash the data and publish it to the blockchain, that's a very localized event, but lots of people could be observing that event and then using it for the proof of existence in the future.
Oh yeah, no, I agree that there are lots and lots of use cases where you don't have flow. I'm simply trying to look at a variety of situations where you do have where you do have some notion of flow as a measure of utility. So yeah, depending on use cases, it may be that those some use cases escape the notion of utility. I absolutely agree. Not debating that at all.
Okay, so then yeah, I guess I would be concerned about picking a particular measure of utility that favors some types of transactions over others. when we want the system as a whole to sort of be a general compute platform that supports all sorts of use cases.
Yeah, no, you're absolutely right. Which is why I haven't put forward any particular proposals yet about validator rewards. But yeah, that's kind of what I've been thinking about.
Okay, cool.
Yeah. So my assumption was, at least for Mercury, that we weren't going to have block rewards, and exactly for the reasons you've mentioned.
Well, I think what we're talking about is seniorage, right? So the block rewards are distributed according to stake weight.
Yeah, it's Nash didn't like the usage of this word, but I still think it makes it easier to understand. It's an interest payment on your bond, where every so many blocks of being bonded, your stake increases by a fixed percentage. But the term seniorage is apparently more accurate from a finance perspective because you're minting new money to do this.
Mm-hmm.
Yeah, so I guess we're not going to have seniorage, right?
I think we are. That's the proposal currently.
There's a meeting that has started happening Friday afternoons, Kent, which maybe Meta might want to invite you to as well, where we've been talking about economics, and there's certain board resolutions that we need to be in line with, and one of those is related to how the amount of rev increases over time.
Yeah, so if you remember what I proposed last time with having the cooperative create anonymous validators that once in a while produce invalid blocks, like I think that is the most use, or I would say the only way to increase block rewards, or like give out block rewards in a way that secures the network. Because otherwise you risk having validators that give garbage or produce garbage blocks to just get their seniorage.
Well, the seniorage was never based on the amount of work. So the problem with the seniorage model would be more you have bonded, lazy validators that are being paid but not doing their job.
Right.
Exactly. Yeah. So I've sort of run through most of the cases. I've written them down somewhere. But the idea is like, if you, as you said, you have lazy validators, and if you start slashing people for being leeches effectively, then to prevent that, what you'll start doing is creating garbage blocks that have little utility, and so on. And so you get into this like weird loop of things that just don't end up working. And so it seems like the only way to produce block rewards is through this idea of having invalid blocks get slashed. And so that's a way to increase the security of the network while producing that same effect, if that makes sense.
So the idea is that slash rewards are new minted tokens?
Exactly. Yep. Or slash rewards from the anonymous validators by the cooperative are your newly minted tokens, because they're not newly minted, right? Because the co-op already has them in their hands, if that makes sense. But
yeah, I guess this is like something that I've not thought about super hard, but sort of wonder about from time to time, is if the co-op itself is solely in charge of being able to produce new tokens, either because they have access to the mint contract or because we, have like a vault, if you will, of tokens that are locked up by the co-op and leak out into the network from time to time. That it feels very, very centralized, that kind of a situation.
I believe Nash's concern was too is what if the co-op isn't around anymore in the future? Then what happens?
Right, which is the idea behind centralization, right? Is that
Yeah.
if something is centralized and it becomes corrupt or disappears, in either case, you're in trouble.
Yeah, I mean, I don't think it. So once all the co-ops revs have been distributed, then you can use that private entropy thing that Vlad was mentioning to do the same thing in terms of, I guess, circulating around bonds. But I guess, yeah, or actually, never mind. At that point, you don't have anywhere to produce block rewards from, though, right? So,
well, Lad's thing about being able to prove after the fact that you had created this invalid block on purpose, you could somehow integrate that into the protocol as like a sanctioned minting event, right? Like maybe just spitballing here, when you bond, you're given a particular block number, and if you make an invalid block on that block number, then like you're not slashed and new tokens are created as a result of that being caught, or something along those lines. Like it just takes the same idea that you have and distributes it so that all participants can make it happen, and then it's no longer sort of based in one central entity's ability to do this.
Yeah, I like that. I actually hadn't thought of that, and that makes sense.
Of course, I have no idea what the details behind that implementation would look like. We'll have to, I guess, chat with Lad sometime about zero knowledge proofs or something.
Whoops, my mic. Yep. Yeah, that sounds good.
But yeah, there's a meeting that we have Friday afternoon about economics. And
validator economics,
yeah. And the goal of that meeting is to ultimately nail down all of these sorts of questions for Mercury in particular.
Yep.
Cool. Yeah. If someone could send me an invite.
I can send you an invite, Kent. Cool. No worries. Yeah, I'll include you.
Sweet. I thought that was a really, really productive conversation. And I guess I'll see all three of you on the Dev Stand-Up in about 8 minutes.
Sounds good.
Awesome, guys.
Okay, bye.
Ciao.
See you then.